Alright, so now we can work through some nomenclature questions. And this first one, being a ketone, we're going to number it starting at the end closest to the carbonyl, which is going to be on the right side. We have a 7-carbon chain, so this would be heptane. We indicate the ketone with the ONE ending, so this would be heptanone. And because the carbonyl, the ketone, is a carbon 2, we have 2-heptanone. In addition, we've got the pair of methyl groups at carbons 4 and 5, so this is 4,5-dimethyl 2-heptanone. But make sure you remember we're not quite done here, because we do have to account for stereochemistry. Both carbons 4 and 5 are chiral, so we need to assign R and S at both 4 and 5. If we look at carbon 4, we have the highest priority group to the left, second one to the right, and third one up. Our hydrogen is already pointed back, so counterclockwise is 4s. We also do carbon 5, 1, 2, and 3, counterclockwise 5s. In question 2, we have an aldehyde, which you may recall makes our life even easier, because we know that by definition, carbon 1 is our aldehyde. So with 7 carbons, we have heptanal, that Al ending, again indicating the aldehyde. In addition, because an aldehyde is always defined as carbon 1, we don't need to put a number on the aldehyde. We can then add in our substituents, 4,4-dibromo, 6-methyl heptanal. And in this case, we're done. We're done because this molecule doesn't have any chiral centers. The two positions, 4 and 6, that have substituents, carbon 4, 2 of the substituents are bromines. So since there's 2 identical substituents, it's not a chiral center. Same thing at carbon 6. 2 of the groups on carbon 6 are methyls, so also not a chiral center. All right, question 3. Again, we're going to start with our carbonyl, and we're going to number around to the left. So we have cyclohexanone, and we don't need a number for the ketone because we can assume that the ketone is carbon 1 because it's in a ring. We can put in the substituents, 5-bromo, 3,3,4-trimethyl cyclohexanone. Do we have any chiral centers? We have 2 chiral centers here. We find them at 4 and 5. At carbon 4, which is down here, our third priority group is the methyl. The hydrogen that's pointing forward is the lowest priority. Our higher priority is to the right because that carbon is attached to a bromine, whereas the carbon on the left is only attached to other carbons. Our arrow goes counterclockwise, which would be S, but because our low priority group, the hydrogen, points forward, we take the opposite, which is R. Similar type of situation for carbon 5. Bromine is highest priority, second to the left, and third up here. Arrow goes counterclockwise, but again, our low priority group, the hydrogen, points forward, and so we have 5R. Alright, number 4. Number 4, we're going to start our numbering down here and go this way. And the reason we do that is because all of the carbonyls get priority over any other substituent, such as the chlorines. So here we just have 6,6-dichloro, 1,3,5 cyclohexatrione. Our last two are a little more complicated, although the numbering in number 5 is pretty straightforward, again because of the aldehyde. But we have a 9-carbon chain. This would be nonenal. But we also have to account for the alkene and the alkyne. So in order to do this one, I'm just going to list everything that we have here so that we don't lose track. We have an alkene at 4. We have an alkyne at 7. We have a bromine at 9. We have a chlorine at 9. We have an alcohol at 6. Because that alcohol becomes a substituent, we call it hydroxy. The ketone at 3 will also be named as a substituent because of the aldehyde that's present, so that's 3-oxo. And then we have 2,2-dimethyl. In addition to that, we have to do E or Z at the alkene, and we do have a stereocenter at 6 and another one at 9. So if we start with the 4, the geometry of that alkene is clearly E because the other two substituents are hydrogens, so opposite gives us E. What about our stereocenter at 6? Highest priority is the OH group, second priority is the alkyne, third priority is the alkene. Goes counterclockwise, but because the hydrogen points forward, we take the opposite. So that's 6R. And then at 9, bromine is highest priority, chlorine is second, and carbon is third. Hydrogen points back, is also R. So we've got our stereochemistry done. Now we need to put our substituents in alphabetical order. 9-bromo, 9-chloro, it's followed by 6-hydroxy, 2,2-dimethyl, 3-oxo, and we'll continue down here. No A here. Known 4-ene 7-ine-al. So remember, as always, with no matter how complicated our nomenclature questions get, it's a matter of going through our step-by-step sequence to make sure that we don't skip any substituents, any stereocenters, or any functional groups. Number 6 is actually going to be a very similar type of question. Again, we've got an aldehyde, which always makes our lives easier because it means that we know that our chain starts at the aldehyde. So again, nonenal for 9 carbons. I'm going to do the exact same thing we did in the previous question. I'm just going to list everything. So at carbon 2, we have a methyl. We have another methyl at 2. 3, we have a ketone. 4, we have a bromine. At 4 we have another bromine. At 5 we have another bromine. 5 is also chiral. 6 is chiral. 6 is also a thiol. And remember, when a thiol is a substituent, we call it mercapto. We have 2 more methyls at 7. And then we have an alkyne at 9. So again, a lot going on here, but it's a matter of going through this step by step. So carbon 5, highest priority is the bromine, second is the carbon to the right, third to the left, goes counterclockwise, but the lowest priority group, the hydrogen, points forward, so that take the opposite is 5R. At 6, the sulfur is highest priority. The carbon to the right with the bromine is second, and the one over here just bonded to carbons is third. Clockwise is 6R. So we took care of those. Now we need the 3 bromine, so 4,4,5 tribromo. Next alphabetically would be the thiol, or 6 mercapto. Then the methyls, followed by oxo, and finally our parent name, known 8-ine al.